Random samples can be simulated by collecting data from a chance event generator, such as a spinner. For example, a simulation is designed to model a 500-fan soccer game where 400 fans, or 80%, are rooting for the home team. In this simulation, each simulated random sample will have a sample size of 20 fans. So, for each simulated random sample, a 5-value spinner with equally likely outcomes is flicked 20 times, where each 1, 2, 3, or 4 that is spun represents a fan that is rooting for the home team. For this trial, 14 out of 20 fans are rooting for the home team. This simulated random sample can be scaled to predict that 350 out of 500 fans at the game are rooting for the home team. Notice that the prediction, 350 home team fans, which is based on a single simulated random sample, does not have to match the actual number of home team fans at the game, which is 400. This variation in the simulation comes from the random chance events generated by the spinner. This simulated random sample models a game where 80% of the fans are rooting for the home team because the probability of spinning a 1, 2, 3, or 4 on each spin is 4/5 or 80%. So, flicking this spinner replaces randomly asking a fan at the game who they are rooting for. Multiple trials of the simulated random sample can be carried out to investigate the natural variation in random samples. In the first simulated random sample, Trial 1, 14 out of 20 spins represented home team fans. For Trial 2, the spinner can be flicked 20 more times and the results recorded in a table. For Trial 2, 17 out of 20 spins represented home team fans. This process can be repeated until there is data for 10 trials. Next, each trial result can be scaled or multiplied by 25 to find the predicted number of home team fans at the game. Notice that the predictions based on each trial or simulated random sample do not always match the actual number of home team fans at the game. This variation in simulated random samples can be explored by plotting the predicted number of home team fans on a line plot. Notice that the distribution of these predictions is centered around the actual number of home team fans at the game, 400. This means that the likelihood of a random sample predicting a result close to 400 home team fans is higher than the likelihood of predicting a result that is further away from 400 home team fans. This result becomes more clear as more and more trials of the simulated random sample are conducted.